week. So, yep. So she was home.
I bet that was funny.
Yeah, it was good. It was good. She worked a few days and other things. So, but yeah. Hello, hello, hello. Whoops, excuse me.
He said, walk straight in front of him.
I don't even check the Chromebook that.
I want to go home already. For real. It's about spring break out where
Like this. Did a good day for food? No.
Like,
One of my friends felt for it.
I cleared the playtime.
Saying that the passion is
Just run it.
I told my mom I was pregnant. She's like, good luck trying to tell your dad that.
Oh, I gotta move quick. I'm not as fast as I was no more. I'm not fast no more. I feel like an old man. I didn't touch my Chromebook. I'll break.
Oh, yeah. I thought you called me.
Light
You're like, Mom, guess what? I'm like, Mom, guess what? You know, I'm pregnant. She's like, good luck trying to tell your dad that. I'm like, I'm just kidding.
She's laughing with you.
Good morning, ladies and gentlemen. How are we doing today? Welcome back. Welcome back. Welcome back. April 1st, ladies and gentlemen. Hopefully today is not your day. So, it's not your day. How do you know? Well, go here. I'll open the door for you. No one's forcing you to be here. I'm definitely. Oh, your mom's a good person. Your mom's a good person. So.
No.
That's good. That's good. You know why they're forcing you to be here? Because they know you would make a good decision otherwise. That's really? So you would be here without her forcing you to be here? No,
Yeah,
see what I mean?
I woke up at 6:20 this
See what I mean?
I woke up at 5 this morning.
It's a good thing you woke up this morning because the other option isn't very good if you never wake up. So.
Yeah, you did.
All right, ladies and gentlemen. Let me get attendance here.
In the L.
Perfect. All right. So, anybody do anything exciting over break? Go anywhere special, win $1 million, be a Powerball winner from New Jersey. Okay, hold on. What, Zoe? Did you?
To get my ACCT certification.
Cool. Ethan, what'd you do?
I did nothing except on Saturday I went to go see a band play at Badger State.
At Badger State. Where's that at? Oh,
it's by like Lambeau.
It's by like Lambeau. Okay. What band?
It's called Sherry Lane.
Do that again. What was the name?
Sherry Lane.
Sherry. Okay, I wasn't sure if you said Sherry or Cherry Land. I'm like, okay. No one else? Nothing exciting? You went to Wisconsin Dells? Where'd you go in the Dells?
Mount Olympus.
Okay, all right. And how was that? Did you ride the roller coaster that goes around and around the what?
They're not open.
The slide?
They're not open like the outside activity.
That's the inside one.
The inside one.
Oh,
the one that Medusa that spins around. You rode that? Okay. I drove by. I saw it spinning.
When I'm on Olympus, we got stuck in an elevator there at a hotel.
Just say the water from the daytime to the nighttime. The nighttime is way colder than the daytime.
The coldest time I ever had in the Dells, we went there and we did that Poseidon wave pull on an August day, and it was cold. Cold.
The water at night is
cold.
It was chilly, that's for sure.
Yep. All right. Anybody else? Exciting, new, something you did? No. All right, ladies and gentlemen. Well, here's where we're at. We are at the basically last 9-week stretch to the school year.
It's crazy.
So not a whole lot of time. All of April, I think there's only one half day that you get one early release day, and that's it. But we'll get through there. So, all right, Kevin, grab your periodic table, and we'll have you do this, and then I will hang back the rest of your tests from before break for you.
Yay.
I know. Actually, you have the test. I just need to give you back some other stuff.
That's really biased to be studying 56 tests for school.
Yeah.
Yeah, it's crazy. He posted stuff like last night. Like,
I'm showing 6. Let me remember.
6.
I should have was 5 right now. So, like, give me
You see that new question?
I want to read it to see my friend and stuff. I was like, I don't want to be here.
Still top rank. Y'all hate that.
All right, excellent. Good. All right, ladies and gentlemen, that's right. I forgot. For you guys, I don't have to hand back your quizzes because you did them online, ladies and gentlemen. So let me hand back some other things that I have, and then I'll hand back your grade sheet, and we will go from there. So, all right. There. All right, here we go, ladies and gentlemen. Ethan.
Yes.
Ellen. Victoria.
Can't you just say pizza?
Mariana.
I was like, oh, okay.
Hey. You're welcome. You'll see.
Alright, we're not gonna buy yellow right now.
Zoe.
We're not gonna yellow right now.
Oh, yeah.
There you go.
I cannot. I hated something and shit.
Christopher.
No, I can't.
I took the
Alex.
Make 43 spell for
Yes.
45 minutes.
Jimena. Jasmine. Ethan. Yeah.
Oh, that's where it is.
All right, ladies and gentlemen.
Yeah.
So let's take a look at your grade reports that I just handed you. Okay? First of all, if something is highlighted on there in orange, that means that it is missing. If nothing is highlighted on there, that means you're not missing anything. I did not even bother to print the homework assignments. Why? Because they don't affect your grade anyway. You're either doing the homework and practicing or you're not doing it, in which case you're not practicing, and if you're still doing okay, well, that's the main thing. Okay? So up at the top, ladies and gentlemen, is your progress grade. 1 of the 4 unit tests done, so that shows you where you're at right now. If you are missing something, it's probably a lab because almost all of you have made up or don't have any missing quizzes from the unit. If you do, I'd be having you do the quizzes. So chances are if you're missing anything, it's a lab, and there were only the 2 labs, the food lab and the electrolyte lab. So if you're missing one of them or both of them, you got to get it done and get it turned in. Okay? So take a look at it. If you have questions, I'll be happy to answer them for you. But otherwise, ladies and gentlemen, like I said, if you don't have anything highlighted in orange, you're not missing anything, and your grade is what it is. Okay? Most of you did pretty well on the test. However, if you scored in the below a 70, you could do a retake on the test if you want. Let me tell you what number would be below a 70. So if you had 38 or less on the test, you're somewhere in the 60%. That means, ladies and gentlemen, that you could do a retake if you wanted. Your retake needs to be done before the next test if you want to do it. And all you need to do is come in and see me. We'll go over a few things. Definitely look at your test that is online. I don't know if I've returned them yet. I probably haven't. Let me double check right away to see if I have or I have not. Because if I have not. Okay, hang on a second. Review. Okay. There you go, ladies and gentlemen. I just returned your test to you. So that you got it back, ladies and gentlemen. If you have any questions, let me know. Faith, I know you took it. Did I give it to you on paper afterwards or what?
You reopened it.
Okay, there it was. I just never imported it, Faith. There you go. So now I can return it to you. Okay. All right. So again, ladies and gentlemen, if you wanted to do a retake, you can. But what I ask is that you go through, look over what you got wrong on the test, come in, talk to me a little bit, and then we can arrange a time when you can do a retake. So questions on anything, ladies and gentlemen? Okay. All right. Today then, ladies and gentlemen, we are going to start a new unit. So again, open up your computers, get logged in. Okay. Today we're going to be able to understand the effects of and the importance of the air that is around us, ladies and gentlemen. Just a reminder, I cannot grade any work that was never turned in. So if your labs were not turned in, I cannot grade them. I cannot give you some points for them, and therefore your scores are lower than they should be. I do get a notice every time you turn something in on Google Classroom. So if you turn it in late, there's no reason to let me know that you turned it in. I know, I get a notification. I go through and I look through all of the things that I have graded and reviewed every so often, normally once a week. And then I'll grade the things that people turned in late and I will turn them back to you. So keep that in mind, okay? Today we're going to start talking about the air unit. Now, the air unit is it is framed around air, just like the water unit was framed around water, just like resources was done around resources. The air unit is really about gases, okay? And we're going to start talking about gases and things like that, okay? Before we do, ladies and gentlemen, we want to begin with a little activity to see what you know about air. So I'm going to ask you to go to joinpd.com, ladies and gentlemen, and enter this code, QQTUKJ. QQTUKJ on joinpd.com. This is going to be a simple true-false quiz. And it's true and false about things that deal with the air around us, ladies and gentlemen. What's that, Zoe?
What are we doing together?
Well, I'll ask the question, you give me an answer, and then we'll tell you what the correct answer was. So it's simple. It's, like I said, it's multiple choice. It's true, false, every question. So we'll give you the question, and then we'll talk about the answers. So if you would, get logged in, and then we will go from there.
Then there's 40 questions.
No, there's 40 slides. Because there's 20 questions and 20 answers. Okay? So don't panic. Here's the other thing. It's not graded. So just give me your honest opinion when you look at a question as to what you think the answer is. All right, ladies and gentlemen, here we go. If you're not logged in, you can keep trying to get logged in so that we can keep going. All right. You could live nearly a month without food, a few days without water, but would only survive a few minutes without air. Is this entire statement true or false? All right. You can change your mind. You don't have to, okay? The statement itself, ladies and gentlemen, sorry. Come on. Come on. Is true. Okay? The statement itself is true, ladies and gentlemen. Air supply is needed for scuba diving, flying at high altitudes, or travel into space, ladies and gentlemen. Yes, we can only survive a few minutes without air. Again, you could go a few days without water. You could go approximately a month. Again, it depends on the person. Not exactly a month, but you can go the longest without food. Water is second, but you'll only survive minutes without air, ladies and gentlemen. Only minutes.
Isn't it because your body holds like your food?
Well, your body, remember last unit, fats, energy storage. Your body will literally start eating its fats, then it will start eating its proteins, or then it will basically, when it runs out of those things, shut down. But that gives you about a month without eating, okay? A month without eating. And again, you can go a few days without water, but if you go longer than that, you'll probably die as well, okay? A little bit of individuality there, but that's the basic thing. But air, we can only survive minutes without air, ladies and gentlemen. That's it. So if you're in a place where there is no air, or if you're for some reason unable to get air, like you were underwater or something, you would only survive a few minutes without it. Okay? The volume of a given sample of air, how much space it takes up, depends on pressure and temperature. So think about a balloon. It occupies a certain volume. If we were to somehow change the temperature around the balloon, if we were to somehow change the pressure inside the balloon, would its volume change? That's what this is asking you. Would its volume change? Okay. So, the correct answer, ladies and gentlemen, is yes. Volume actually depends on temperature and pressure. Now, a little bit later, we will talk about the different gas laws. But think about this. What happens if you buy a balloon for like Valentine's Day and you take it out of the store in Wisconsin?
It slowly starts to deflate.
Slowly starts to deflate. It actually isn't deflating. Anyone know what is happening to it?
It gets cold, so the air inside of the balloon, like once you bring it back to warm temperature, it'll go back to like the full size.
Good. I was hoping you were going to explain, though, because you started really good with when it's cold, the air inside gets what?
Cold.
The air inside gets colder and it takes up less space. The air inside gets colder and it takes up less space. So yes, it looks like your balloon is deflating. However, when you put the balloon back inside to a warmer environment, either a heated car or a building that is heated, it'll go back up to its normal size.
We had a lot of people, because I work at Flowerama, so we had our whole ceiling full. And a lot of people were like, well, my balloon is deflating. We're
Yep.
Like, no.
All those places, Party Perfect, Party City, Flowerama. If you sell a balloon, you better understand this, because people will walk outside, their balloon will start deflating, they will come back in and want their money. And if you keep them talking long enough, ladies and gentlemen, the balloon will reinflate. You can be like, what's wrong with your balloon? It's perfect. Okay? All right. Air and other gases are weightless. The air around us and other gases are weightless. In other words, they have no mass. True or false? Okay, I'm interested in seeing where you went with this one, ladies and gentlemen. Nicely done. Air is a form of matter. All matter has mass. All matter takes up space. So yes, even the air we breathe, ladies and gentlemen, has mass. Now, what confuses people is helium will do what? Helium will float. That does not mean it does not have mass. An empty helium balloon and a filled helium balloon have different masses.
Yeah, I figured that out. So
and even a tank of helium, the way they know when it is getting low, besides the pressure, is you could take and you could mass it. It will have less mass.
Oh, some people like use helium in a balloon, like to suck it up and like change the voice.
True, but again, not quite what we're talking about here. But yes, go ahead.
I figured that out because I forgot yesterday was my uncle's birthday, so we went over. I forgot to blow the balloons up, so I just stuck a straw in the balloon and blew it up, and it didn't float. So I needed like.
Right, but the air that you breathe, if you take an empty balloon and find its mass on a balance and then blow air into it, it will have a larger mass after you blow air into it. Okay? Will have a larger mass when you blow air into it. The atmosphere exerts nearly 15 pounds of force on every square inch of your body. The atmosphere pushes down on every square inch of your body, on your head, on your cheek, on your face, on your arms, any place that air can touch right now is pushing down with a force of about 15 pounds on every square inch. True or false? Not quite so many willing to give an answer here. That is true. Right now, the air in this room is pushing down on every square inch of your body with about 15 pounds of force. Yes, that is the same 15 pounds that if you went into the weight room and grabbed a 15-pound barbell, that is the same exact weight. So why don't we feel it? Since the day you've been born, you've been living under that pressure. From the day you have been born, that pressure has been on you. We don't even notice it. However, over the next few days, ladies and gentlemen, we'll give you some demonstrations that show you that this actually exists and what it actually does to your body. Okay? So we will get there. Components of the atmosphere vary widely at different locations on Earth. In other words, ladies and gentlemen, the air that we are breathing here in Wisconsin, is it different from the air at the North Pole and the South Pole? Is it different from the air in Philadelphia, in California, in some other country? Or is it all basically the same? This is saying that the air varies widely, meaning it would be very different depending on where you are at, ladies and gentlemen. 8 say true, 4 say false. The correct answer, ladies and gentlemen? What? Oh, I'm sorry. I was reading the same thing you were. I saw the word true, and I'm like, wait. It's false. If this were true, living organisms would be much more limited to where they could survive. So the air in basically wherever you go on the planet is the same. Now, granted, if you go to a city like Philadelphia, a city like Detroit, they may have more issues with pollution and smog and things like that. However, in reality, the air is not that different there than it is here. Okay? The majority of the air we breathe, wherever we go, is basically the same. But in certain cities, in certain areas, there may be small differences in things like smog, pollution, things like that, but it's not enough to where we say it was really different. Okay? It was really different. All right. The atmosphere acts as a filter to prevent some harmful radiation from reaching the Earth's surface. Is this true or false? So the atmosphere around us, the air, stops harmful things from getting to us. True or false? Very good. That is true. Most of the harmful high-energy ultraviolet radiation is absorbed by ozone or other triatomic species, carbon dioxide and water vapor. Okay? So, The sun, ladies and gentlemen, is a giant nuclear reactor. And if you remember in the last unit, or in a unit ago, we talked about electromagnetic energy. So the sun produces things like gamma rays and X-rays and ultraviolet. What does ultraviolet do to you?
Make people blind.
No. Ultraviolet is the stuff that tans your skin. However, it can also burn your skin, and it can also lead to things like skin cancer. So, ladies and gentlemen, there are things in the atmosphere that absorb that keep that from reaching us. Okay? In the part of the atmosphere nearest to the Earth, the air temperature usually increases as altitude increases. So, in other words, if you were to go up 500, 1,000, 1,500, 2,000 feet into the air, this is saying that the air pressure or the air temperature will increase as you do that. So does it actually increase? Good call by the people who said false. It actually decreases. What on the planet gives us an example that the air temperature decreases as you go up? What? Mountains. Think about mountains. The top of mountains is normally covered with what? Snow. Okay? Covered with snow. Now again, you've got to get fairly high up for this to happen, for there to be a big temperature difference. But yes, normally the temperature is decreasing as you go up into the atmosphere. Minor components such as water vapor and carbon dioxide play major roles in the atmosphere. Minor things in the atmosphere. Carbon dioxide, water vapor play major roles in the atmosphere. True or false? Good. You were paying attention earlier to the question that talked about how the filter was done by things like carbon dioxide and water. Atmospheric water is part of the hydrological cycle, meaning the water cycle. Okay? Also, together with carbon dioxide, it plays a crucial role in helping maintain the heat balance on the planet, how hot the planet is. Okay? So, again, those two things help filter out things from the sun that are harmful to us as well. Okay? 2 of the 10 most produced industrial chemicals are obtained from the atmosphere. 2 of the 10 most industrial chemicals are obtained from the atmosphere. Not quite as sure on this one. Taking longer to answer. True. Oxygen is the number 5 industrial chemical needed. 35 billion pounds per year in the U.S. on the top 10 substance list. This atmospheric gas is used for welding, medical purposes, propellants, and steel production. Nitrogen is number 3 at 37 billion pounds per year. This atmospheric gas is used as an inert gas for metals, electronics, and for freezing agents for food, cryogenics, and the production of ammonia. Okay? Also, nitrogen is important in fertilizers, ladies and gentlemen. And those are 2 things that we get right out of our atmosphere that we can use. Okay? All right. Ozone is regarded as a pollutant in the lower atmosphere, but an essential component in the upper atmosphere. So ozone. Anybody know what ozone actually is? What? It's not exactly oxygen. Oxygen is O2. Ozone is what? Psst. Hey, Jaslyn, come on. Okay? I know you haven't seen each other in a week, but... What? Sorry, I didn't hear you. I cannot hear a word you're saying. I'm sorry. So, Well, thank you, Jaslyn. I'm glad you approved much of what I'm doing. And I really don't care if you do, because this is what I'm supposed to teach you. And again, if you don't like it, Jaslyn, there's 27 doors in the building. Pick your favorite and leave. It's your choice. Okay? I'm not trying to be a jerk here, Jaslyn, but there are some people who are trying to learn, and you're bothering them. So,
I'll fix the problem and I'll leave.
again, all I'm asking you to do is pay attention.
I haven't.
Okay, good.
If I wasn't paying attention,
Okay,
I would have been participating in your paradox.
I understand that, but you're also distracting others around you, which is unfair to the other people. So, sorry for that. Okay? All right. So, ladies and gentlemen, ozone, yes, it is important in the lower atmosphere. Okay? It produces photochemical smog that corrodes metals, plastics, and other major health hazards. But in the upper atmosphere, ozone filters those harmful things that come from the sun. Ozone is actually O3. It is not O2. It is different from oxygen. Oxygen is O2. Ozone is O3. Okay? So, again, it has a purpose in part of our atmosphere and another part, not so much. So, okay, questions? All right. Clean, unpolluted air is a pure substance. Please remember, a pure substance is either an element or a compound, ladies and gentlemen. So is clean, unpolluted air a pure substance?
Wait, what is it again? Sorry.
A pure substance is either an element or a compound. One or the other. So is the air that we are breathing a pure substance? Gotta get my cursor back over on the right screen. All right, so most of you got this one wrong. Air is actually a mixture. It's a mixture of two major ingredients and a few minor ones. The major things being nitrogen gas and oxygen gas. The minor ones being things like argon, carbon dioxide, and water vapor. Okay? All of them are important, but these are the two that are the major things that are in the air. But it's a mixture. Now that mixture is the same wherever you would go, which makes it, anybody remember what kind of mixture it is when it's the same ratio no matter where you go? Word for the same? No, a prefix. I'm sorry, I shouldn't have said word for the same. Prefix for meaning the same, homo. It's a homogeneous mixture. It's the same basically everywhere you go, ladies and gentlemen. Air pollution was first created during the Industrial Revolution. So air pollution on this planet first started happening when we started making things, is what this is saying. Making cars, building things, industrializing our nation. Air pollution, is that when it first started occurring? Good. False is true. Air pollution is as old as people are. Air pollution actually predates people. Why? The planet had vegetation on it. Lightning strikes would burn the vegetation, burn forests, burn things. That's pollution. Okay? So that was happening basically since the dawn of time. Okay? But even early times for cooking food, for keeping warm, they would burn fires. Fires creates pollution. Pollution ends up in the atmosphere. Okay? Now, the Industrial Revolution has caused an increase in the amount of air pollution, in the amount of things that we are putting into our atmosphere, but that's not where it started. Okay? No human deaths have ever been directly attributed to air pollution. Has anyone ever died from air pollution? And I would go with false. It's false. Or that is True. Human deaths have been directly attributed to air pollution. Okay? So when it says no human deaths have ever been directly attributed, that would be false. Correct. Air pollution has caused human deaths. And in cities, big cities, others, even in Green Bay, in the morning, they will issue a warning for people who have breathing problems that the air pollution level is like this in the area. Okay? And again, Green Bay is not really considered a very bad city for that. But if you go to more industrialized cities, if you go to California where they have mountains that stop pollution from moving around as much, they will put out a warning that says, hey, if you are a person who has health issues, you may want to stay inside today. And people have died from the amount of pollution in the air. Okay? Natural events such as volcanic eruptions, forest fires can produce significant air pollution. Again, we'll see if you were paying attention earlier. That is true. The eruption of Mount St. Helens and Mount Pinatubo volcanoes and forest fires ravaged dry western states, vividly demonstrate sources of natural air pollution. Think about, think about the fires in Maui, the destruction that they caused, the amount of pollution that they created. Okay? Again, these things have been going on since the planet has been around, ladies and gentlemen. Okay? Destruction of materials and crops by air pollution involves a significant economic loss to our nation. In other words, costs our nation money because of air pollution and a significant economic loss. Just about there, ladies and gentlemen. Only a few more questions. That is definitely true if you consider $16 billion annually a significant economic loss. That's loss of crops, that's loss of life, that's loss even having to go out and clean things because of the air pollution in cities. Okay? $16 billion annually every year. The main source of air pollution is industrial activity, factory. Factories are the main source of air pollution, true or false? That, ladies and gentlemen, is false. You and I are. Because if you think about it, there are a lot of factories, yes, but there are 7 billion people on the planet. 7 billion people who need to get from one place to another, 7 billion people who need to heat their homes, 7 billion people who need to cook their food. We produce a lot more air pollution than do factories. Factories created in one area. We are spread out over the entire planet. Okay? The greenhouse effect is a natural warming effect that may become harmful because of excess burning of fossil fuels. True or false? Hopefully we don't need a long time on this one, ladies and gentlemen. True or false? What do you think? This one is true. Okay? And they talk about this all the time, ladies and gentlemen. Okay? If the planet warms up too much, that will be a bad thing for you and I. Why? Because right now at the poles of the planet, there is water in the form of ice. Ice doesn't take up as much space as water does. And if that stuff starts to melt, ladies and gentlemen, the water levels in our seas will rise. And that can lead to major difficulties. Not only that, ladies and gentlemen, but global warming, people think, oh, great, planet's a little bit warmer, it'll be hotter in summer. No. Global warming causes major swings in temperatures, extreme highs in temps, extreme lows in temps. That's all part of global warming, ladies and gentlemen. Okay? In recent years, rain in industrialized nations has become less acidic. In recent years, the rain in industrialized nations has become less acidic. Thank you, sir. The rain in industrialized nations has become more acidic, causing both environmental and political problems, ladies and gentlemen. Okay? It doesn't seem like a big deal, but acid rain, when it is created, things that are acidic often do what to other things? Tarnish, corrode, eat away at them. Now, we're not talking about rain that is so acidic that if you stand outside in it, it is going to, corrode your skin. It's going to burn your skin. No. But over time, buildings made of limestone, buildings made of concrete, buildings made out of certain materials that get exposed to acid rain, it will literally start to wear away at them. Will start to wear away at statues, will cause metals to react and to start to corrode or decompose over time. A lot of bad things can happen with acid rain. Okay? And acid rain is basically a byproduct when certain pollutants get into the atmosphere. They mix with the water in there and make it acid rain. Okay? Most air pollution caused by human originates with burning fuels. So think about the fuels that we burn. We burn them to get to and from in cars. We burn them to heat our homes. We burn them to cook our foods. Okay? Good. Major combustion products are carbon dioxide and water. A variety of other substances such as unburned hydrocarbons, some nitrates, some sulfates, and particulates. So yes, okay? Burning fuels causes all of that stuff. Now you may be wondering how does it cause this stuff? Well, these are impurities that can be in the fuels that we burn and things that we burn. So they end up getting released and into the environment as well. All right. Air pollution has not improved overall air quality. Or let me rephrase that, I'm sorry. Pollution control, things that we have implemented to try to get rid of some pollution have not improved overall air quality. True or false? The question, as it is stated, has not improved overall air quality would be false. It has. We have gotten better. They have made it so that smokestacks out of factories, while they may still release things into the air, they don't release as many pollutants. They don't release as much sulfur that would get into the air and cause acid rain. So yes, we have made an improvement in air quality over the years, ladies and gentlemen. Okay? And things that we are doing is helping. Okay? So there is some good news on that horizon there. All right. If you would, ladies and gentlemen, please open up the new EISN that I've given you. Okay? The new EISN I've given you starts with this slide. This is the first slide in it, ladies and gentlemen. So please open it up. Now, this slide we have already given you. We have already been through in this course. We did it when we did the states of matter. I'm not going to spend a lot of time on this, but because this unit is on gases, this is the important part that we're talking about down here. So what do we know about gases? Gases have no definite shape. Gases have no definite volume, meaning they will take up as much room as you give them, meaning whatever container you put them in, they will take the shape of that container. Liquids take the shape of their container, but they don't necessarily fill it. Gases do, okay? Gases have a very high energy. They are the particles that are moving around the fastest. They also, ladies and gentlemen, are very far apart, okay? They have high energy, and they are moving the fastest of any state of matter. The particles of air in this room are doing that, ladies and gentlemen, okay? Now, again, this whole unit, the way we are going to approach it, ladies and gentlemen, we are going to look at relationships. For us to look at relationships, there are two kinds that we're going to look at. One is a direct relationship, meaning a relationship where as one variable changes, the other variable goes in the same direction, okay? So if you increase the temperature of a gas, what happens to its pressure? What happens to its volume? What happens to the amount of gas? If they're both going in the same direction, that is called a direct relationship. Mathematically, it means we will take one variable and divide it by another. Okay? So think about the speed a vehicle travels at. Speed is distance divided by time. That is a direct relationship, meaning the more time you drive, the further distance you will go. That is what we mean by a direct relationship, ladies and gentlemen. And we have talked about this before. All right? The opposite is an inverse relationship. And it's a relationship where as one variable changes, the other goes in the opposite direction now. So now you've got things that are moving in opposite directions. One thing is going up, one thing is going down. This is the opposite of a direct relationship. So what's the opposite of division? Multiplication. So mathematically, you will have one variable times another. That's how we will recognize it as being an inverse relationship. If you are multiplying the two things together, that is an inverse relationship. If you are dividing them, that is a direct relationship. So an example, ladies and gentlemen, would be from our last unit. As the mass of water increases, the change in temperature decreases. That is an inverse relationship. Given the same amount of energy, if you have more water, the change in temp is going to be less. Okay? The change in temp is going to be less. Questions? Okay. So again, the biggest difference between chemistry and conceptual chemistry. In chemistry, we would do all these problems and we would solve them to get numbers. In conceptual chemistry, we are going to do these and we are going to solve them to make them, to figure out if it is an inverse or if it is a direct relationship, ladies and gentlemen. Okay? So we are going to look at these relationships rather than the math. But again, the type of math tells us what type of relationship it is. Questions? Okay. Let me know when you're done. So you good?
Yes.
Anybody else need more time? All right. Okay. We talked about inverse and direct. The other type of relationship is a constant relationship. What does constant mean? What? Okay, constant means something is the same. Something does not change. Okay? So it is a relationship whereas one variable changes, the other changes at the same rate. Before they were going in the same direction. Now they're going at the same rate, meaning if this thing doubles, this thing doubles. Okay? Same rate, ladies and gentlemen. If you're looking at a graph, the main thing is you will see a straight line. Doesn't matter if the line is going up, doesn't matter if the line is going down. If the line is straight, it is a constant relationship. Okay? And you can be constant and direct. You can be constant and inverse. Okay? Second type is what is called a non-constant relationship. As one variable changes, the other changes at a different rate. Same rate, different rates. So now your graphs, ladies and gentlemen, will be curved lines. Again, doesn't matter if the line is going up, doesn't matter if the line is going down. Doesn't matter how it's curved. Okay? This one starts out going slowly and then increases fast. This one starts out changing fast and then slows down. The main thing is if your line is curved, it's non-constant. If it's straight, it's constant. Questions? So we are going to be making and looking at a bunch of graphs in this unit as well. Okay? So if your graphs are straight line, it's a constant relationship. If your graphs are curved, it is a non-constant relationship. By the way, this one is constant because it's a straight line. Because it's going up, what other kind of relationship is it? Direct or inverse? Direct. This one would be inverse. So again, if the line is going up, it is direct. If the line is going down, it is inverse. If it is going straight, constant. If it is curved, non-constant. So is this an inverse or a direct? Why? Because it's going up. Inverse or direct? Still direct. The line is still ultimately going up. So if your line is going up, it is direct. If your line is going down, it is inverse. And then the shape of that line tells you constant or non-constant. All right. So the one gas that is all around us, ladies and gentlemen, the one gas that is here for all of us all the time is air. Okay? Now, air is actually a homogeneous mixture. We talked about that in our introduction. Homogeneous means what? The same throughout. No matter where you go, it's going to be the same. What is the air we're breathing made up of? What is the main ingredient in the air we're breathing? No.
Carbon dioxide.
Nope. 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 Main ingredient in the air we're breathing? Nitrogen gas. Nitrogen gas. 78% of the air we're breathing is nitrogen gas. What do we use nitrogen gas for, ladies and gentlemen? In our bodies, what do we use it for? Not a darn thing. We inhale it, we exhale it, no use in our body. None. We can't take just the oxygen out of the air and breathe it, so we have to inhale nitrogen as well. Gets in your lungs, the blood goes and picks up the oxygen, distributes it through the body, leaves the nitrogen there, you exhale it. Okay? Leaves the nitrogen there. So it's evenly distributed. It has a definite ratio. It's made up of various components that vary just slightly at different locations. We talk about how there can be more pollution in one area than another, but ultimately, the air everywhere on the earth is 78% nitrogen. What's the next percent? Or what is next, I should say? Next is oxygen. Oxygen is number 2. 21% is kind of important too, ladies and gentlemen. What would happen if the earth had a little less oxygen in the air? What do you think would happen? Some people would die. People with breathing problems, people with poor lungs might not be able to breathe or would need oxygen with them to stay alive. Now, if there was a few more percent of oxygen in the air, 25, 26, 27% oxygen in the air, what would be the bad part about that? What would we have a hard time stopping? Fires. Fires. We would have a very difficult time putting out fires if there was a little bit higher percentage of oxygen in the air, because they would burn even better. Okay? So forest fires that start in certain areas, we would never be able to put them out if there was too much oxygen in the air. By the way, what percent is this? 99. Majority of the air that we're breathing is 99% these things. Now, there are other things. 1% of other things. Water vapor, carbon dioxide, the things you guys talked about. Other gases that are in the air. But the majority of the air we're breathing is either nitrogen or oxygen gas. Okay? Nitrogen or oxygen gas. Now, there are 4 things that affect the gas, and we will be talking about these all unit long, so make sure you get these down. Number 1, ladies and gentlemen, pressure. Pressure is what a gas exerts on something. Okay? So, pressure is the number 1 thing. Okay? It is the amount of force applied to a certain area. That is what pressure is, ladies and gentlemen. Number 2 is volume, the amount of space that something occupies. So the gas in this room right now is putting pressure on us, and it's occupying the space of this room, ladies and gentlemen. That's 2 of the 4 factors. Third factor, temperature. What is temperature? And please don't say how hot or cold it is. What is temperature actually?
Average kinetic energy in the particles.
Good. The average kinetic energy in the particles of matter. What does kinetic energy mean? They're moving. What two things affect kinetic energy? Mass and? Nope. That's potential energy. Mass and speed. So in this room, there are oxygen particles, correct?
Mm-hmm.
Now, depending on the day, the temperature of those oxygen atoms can change, right?
Mm-hmm.
Okay? If it is hotter, what does that mean for the particle's kinetic energy? It's going to go up. How does the particle's kinetic energy go up?
Because you're heating.
What does it have to do? I'm not saying you're creating anything. We just agreed that if the temperature of the air outside is hotter, the particle's temperature goes up, which means their kinetic energy goes up. So if mass and velocity affect kinetic energy, which one of those changes about the particles? Yeah, you can't change their mass, can you? The oxygen particles in this room have a certain mass. You can't change that. But what we can change is how fast they're moving. So today, outside, the oxygen particles are moving how compared to the ones in this room? Slower. Why? Because it's colder outside than it is in the room. So the particles outside are moving slower than the ones inside. Why? They have less kinetic energy. They have less kinetic energy, they are moving slower. So in terms of temperature, that's how we're going to think of it. How fast the particles are moving. How fast? Because we can't change their mass, but we can't change how fast they are moving. By the way, temperature must be in a unit called Kelvin. We'll explain what that is in just a few minutes. And finally, ladies and gentlemen, the fourth factor that affects a gas is the amount of gas. How much gas there actually is there? When do you put more gas in something? When do you change the amount of gas in something? Give me an example. When you blow up a balloon. There's no gas in it to begin with. As you blow into it, more and more gas. What happens to the balloon? Which changes which other one of these?
Volume.
The volume. If you are going to change any one of these four things, something else has to change as well. Something else has to change as well. You put more gas in a balloon, its volume gets bigger. We talked earlier about Victoria selling a balloon to somebody. They're going outside on a cold day. What changes when you go outside? The temperature. The temperature gets lower. What happens to the volume of the balloon? It decreases. Two of these things changing at the same time. Yes, sir.
So I know that when we use the balloon example, the amount of gas and volume increase. But would the pressure increase as well?
No. It does not. Pressure can change at times, but not in that case that we're talking about there. Okay? And we'll explain why as we get into this a little bit more. By the way, the amount of gas is the number of particles of gas present. Anybody remember how we measure number of particles? What unit it is? Of the 7 base units up there? Mole. Very good. Measured in moles. Okay? Measured in moles. So, if we take a look at this, ladies and gentlemen, pressure. We're going to use a capital P for pressure all unit long. Here's the units that we'll talk about. mmHg stands for millimeters of mercury. ATM stands for atmosphere, how much pressure the air around us puts on us. PSI is pounds per square inch, and kPa is kilopascal. We'll get into talking about what that unit is in a minute. For volume, ladies and gentlemen, there are 3 units we will use. We will either use liters, milliliters, or cubic centimeters. So liters and milliliters and cubic centimeters, we can measure those in the lab with a graduated cylinder and things like that. It's harder to measure a gas though. Why? Because we have to get it separated. Temperature. Now, a lot of times you'll be given it in degrees Celsius. If we take the temperature in the room, that's what it will be. Well, for gases, we have to put it into Kelvin. We'll explain why when we get into talking about Kelvin, but we have to put it into Kelvin. And then finally, ladies and gentlemen, amount of gas the unit for that is going to be mole if we're going to use any unit at all. Okay, any unit at all. Okay, all right, so, all right, let's talk about pressure. Okay, let's talk about pressure, ladies and gentlemen. Pressure is the amount of force applied over a certain area. That is the definition of pressure. Okay, so I need a volunteer. Who's willing to volunteer to help me here? Anna, come on up to the front, please. Yeah, let's do that. Right there. You just need to stand right there for a second, please. Okay? So, we're going to do a little demonstration about pressure, ladies and gentlemen, and Kiana is going to help me with this. Okay? Are you good at standing?
Yeah, I think so.
Good, because that's what you're going to be doing. Okay? That's what you're going to be doing, is standing. And we're going to use a bed of nails for this demonstration. Okay? We're going to use a bed of nails for this demonstration. And Kiana, you're going to stand on the bed of nails. Can you do that? Yeah. Excellent. Excellent. So, here we go, ladies and gentlemen. Kiana is going to stand on a bed of nails.
Can you do it first?
Can I do it first? Certainly.
Okay.
Okay?
Yeah.
Now wait. Wait.
Okay.
We got to get this ready for you to stand on it. Okay? Are you ready?
Okay.
Okay, good. All right. So you are going to stand on this bed of nails. Okay? All right. Use the table and use, Victoria, can you slide yourself over so that, yeah, thank you. And use this desk to steady yourself before you stand on it, okay? Now, I have 2 rules for you.
Don't hurt him.
2 rules, okay? Try to stay as steady as you can. Don't rock back and forth.
Oh, I won't.
And the bigger rule, don't jump.
I won't jump.
Okay, all right. All right. So,
You really scared me.
So-
Listen, man, you have life insurance, right?
I'm not sure if it's paid up, but I originally did, yes. Okay, all right.
Are you ready?
You
Here, let's hold that closer.
All right, I think I'm ready. Okay,
You think you are?
I'm ready.
Okay.
I'm ready. I'm ready.
Does it matter how much I weigh?
Yes, but I guess we're a little late asking that now. All right.
Okay. Ready?
Yep. Oh! Kidding. I'm kidding. Oh my gosh.
Is this good?
Yeah, this is pretty good. How's it for you?
Good.
Oh, actually, this is not bad.
God, Jesus. I got nervous. My bad.
You got nervous. Okay, you ready to try again?
No, she's like, hell no. Sure.
Just stay nice and wide base. You'll be fine.
You just gotta stay balanced.
Yep, all you gotta do is stay balanced.
Okay.
If you have to hold
There
on,
you go.
hold on.
Yeah.
Oh.
You're
Can you hold on
doing,
to
you're
the
doing
desk?
wonderful. You have got the harder job, and you are doing absolutely wonderful.
Yeah. I can feel you breathe.
Can you?
Yes.
Okay. Well, maybe it's time to get off then. Just a little bit, but please. Okay, thank you.
I try to make it as comfortable as possible.
You did. You did a wonderful job. Now, we gotta check something, ladies and gentlemen.
Mm-hmm.
Okay.
You're not punctured, are you?
Well, let's find out.
No, he's not going on. He's okay.
Hey, no leaks. Good. Hey, you're not done. Come on back up. Okay. Come on back. What?
I thought I was going to crush you.
Well, now we need to change something.
Okay,
Pressure, only 2 things affect pressure. Force and area. Okay? So let's start by changing the force. So Ethan, come on up here too. Okay? So we're going to change the force because, again, you have a certain force, correct?
Yes.
Ethan, you have a certain force, correct?
Yes, sir.
Okay, well, let's see what happens when we change the force here. Okay? So you're both going to stand on it.
What?
Okay?
Ethan, how, balanceable are you?
Pretty balanced.
Okay, good, because again, no rocking and no jumping. All right. Okay, you guys both got to get
We're
on.
both gonna get on there.
That's up to you to figure out. Okay, let's go.
You get up in there.
Okay.
Yeah, you went up there first because then that'll take longer. Okay, yeah.
Okay.
Now you got to either be in front or behind her, so why don't you slide up toward me? Okay, spread out your feet. There you go. Now we're doing good. Now we're doing all right. Now the nails are really starting to hurt. Okay, can you guys get off, please? Thank you.
You okay, Mr. Williams?
Oh, I've never been better, Zoe. Never been better. Okay, what did we change?
The amount of weight.
Okay, but remember, for pressure, two things. Force and area. What did we change?
The force.
Force. What happened to it?
The pressure.
It increased. Okay, it increased. So what happened to the amount of pressure I felt? Should have increased more. Yes, it did. It did. Okay, now, Ethan, feeling lucky today?
Sure.
Okay, lay down.
Oh.
Now, to be fair, we need to use Kiana again because she provided the original force. Go ahead and lay down. But there is another factor we can change, which is what?
Adding a different person.
No. We changed that. That was the force. We said force and area, right?
Yeah.
Now, people normally get freaked out by the bed of nails. So for Ethan, we have something a little bit easier. We have a bed of nail. Okay?
Yeah,
So, Kayana, you're going to stand right on top of this nail. Right on top of Ethan. Let's see if we can find right there, right between the B and the T of basketball. Can you hold your hand right here? Okay. So, Kayana, it's really difficult, but you need to stand right on that nail. Okay? Right on that nail.
Are you sure I won't impale him?
I'm probably pretty sure that you will. But he willingly volunteered, so he said this is okay.
Ethan, there ain't no life contract here, so we're good.
You're gonna get fired.
So you're going to do it or no?
No.
Okay, I'll do it. Actually, don't. No. We wouldn't want to do the bed of nail. Why?
Because it's gonna go through.
Why?
Because
Ethan, I'm scared.
there's more
I'm scared.
like
Now,
I'm
think,
scared.
slow down.
for the bigger one, they're spread out.
Okay, go ahead and sit
Or
down.
for the bigger one, there's
There's more what?
weight.
Nope.
Wait, like
No.
Come on. Two factors.
One huge nail.
Two factors.
More pressure.
And two factors for pressure. What and what? Surface what? Area and force. Two people change the what?
force.
One nail changes the surface area. Now, what is the surface area here compared to here? Which one is more? This one's bigger. This one's less. So now all of Kiana's force will be on a much smaller area, which means what will happen to the amount of pressure? It'll go up, which means the nail will go right through Ethan. Okay, I got a hammer in the back. We could have taken it out of the floor. That wouldn't have been a problem. Okay? Now, going through Ethan's organs, that could be a problem. Okay? That could be a problem. Okay?
What if she really would have done it though?
I would have stopped her before she got too far. Okay? It wouldn't have gotten too far into his chest before I would have stopped her. Okay? So basically, ladies and gentlemen, what we're saying is that pressure actually has two things that can affect it. It can be affected by the amount of force, and it can be affected by the area of the object. Okay, good. So on our next slide, ladies and gentlemen, okay, for the first one, when we used two people instead of one, what happened to the amount? What did we change in the first one with using Kayana and then using Kayana and Ethan? What did we change?
The amount of pressure applied.
By changing the what? We
We
changed the amount of force. That is what we changed. Okay? Now, you are correct when you say something else changed because of that. So we increased the amount of force. Oops. Force went up. What happened to the area? The first time, large bed of nails. The area did what? Did it change?
No.
Stayed the same. But what happened to the amount of pressure? Increased. Okay, what kind of relationship is this, ladies and gentlemen? This is a direct. This is a direct relationship. Okay? Now in the second one, which Ethan chickened out, using Kayana would have left the what constant? The force. Her mass didn't change from the first time to the second time, right? But we would have done what to the area with the one nail? We would have decreased the area. What does that do to the pressure? Increases it. Increases it. This, ladies and gentlemen, is a what kind of relationship? This is an inverse relationship. This is an inverse relationship. Okay? So this is an inverse relationship, ladies and gentlemen. So when you see these circus performers and they do the bed of nails and there's a ton of nails there, what does that actually do for them? What? It hurts them less, actually. The more nails that are in this bed of nails, the less pressure there is. Okay? How many of you have ever stepped on a nail in a board? What happens? Goes right through your foot, right? Right up through your shoe. But I stood on this bed of nails and didn't have a problem. Why? Because there were multiple nails here. And my force was spread out over a larger area. So because there was a larger area, not as much pressure. One nail, same amount of force, a lot more pressure. So Ethan really didn't want to do this, even though he said he did, but I didn't believe him anyway, ladies and gentlemen. I don't think he really wanted to do
I
that.
was like scared.
You were scared? Ethan was probably more scared than any of us, ladies and
I was
gentlemen.
like